China recently deployed automated port cranes that can unload an entire cargo ship 30% faster than human-operated systems, while collecting real-time logistics data. In this footage from Shanghai's Yangshan deep water port, you're seeing AI-controlled cranes coordinating thousands of containers with zero human intervention. Today, I'm breaking down 8 real technologies reshaping global supply chains, what they do, how they work, and where the limits are. Starting at number 8. At number 8, fully automated port infrastructure. China operates the world's largest network of unmanned container terminals, with AI systems managing crane operations, container routing, and vessel scheduling. As you can see in operational footage from Qingdao Port, these systems process over 40,000 containers daily without direct human control. The technology works through computer vision identifying container codes, machine learning predicting optimal stacking patterns, and automated guided vehicles moving cargo. This matters because ports are global supply chain choke points. Whoever controls port efficiency controls trade velocity. The limitation: weather conditions and non-standard cargo still require human oversight, but the next entry is already proving itself across thousands of manufacturing facilities. Number 7. Distributed sensor networks for factory coordination. China has deployed over 2 billion industrial IoT devices, creating real-time production visibility across supply chains. These are operational systems recording temperature, vibration, throughput, and quality metrics every second. The mechanism is straightforward. Low-power sensors transmit to edge computing nodes that identify production bottlenecks before they cascade. Why this matters isn't just efficiency, it's predictive control. When a supplier 3 tiers deep has a quality deviation, the system flags it before defective components reach assembly. The constraint: standardization remains inconsistent across different manufacturers, creating data silos, which brings us to the technology connecting those silos. Number 6. Distributed ledger systems for supply chain transparency. China's BSN, blockchain-based service network, now tracks components across 43,000 companies, creating immutable records from raw material to finished product. In recorded demos, you can watch a smartphone's supply chain traced through 130 parts and 17 countries in under 3 seconds. Here's how it works. Each transfer point cryptographically signs the transaction, creating a tamper-evident chain of custody. This solves the authentication problem. Counterfeit components become exponentially harder to introduce when every handoff is verified. Here's why this matters. In aerospace and medical devices, component provenance isn't optional, it's life-critical. The limitation is adoption. The system only works when all participants use compatible standards. And that's where the next technology creates forcing functions. Number 5. Integrated digital customs and trade processing systems. China's single-window platform processes 95% of the country's trade documentation electronically, connecting customs, quarantine, tax, and logistics systems. These are real transactions. Over 200 million trade declarations processed annually with average clearance times under 2 hours compared to days with paper systems. The mechanism combines document verification algorithms, automated tariff classification, and risk scoring models that flag suspicious shipments. Why this matters beyond speed: digital systems create leverage. When your trade platform sets the technical standards, other countries must adapt their systems to interface with yours. That's soft power through infrastructure. The constraint: cybersecurity vulnerabilities scale with connectivity. One breach potentially exposes millions of transactions. But impressive cyber capabilities lead us to number 4. Number 4. Autonomous satellite networks for global cargo visibility. China's Tiansuo constellation, currently 72 satellites with plans for 300, provides real-time location data for shipping containers, trains, and trucks across Belt and Road Initiative routes. In operational footage, you can see the system tracking individual containers from Chongqing to Rotterdam with position updates every 10 minutes. The technology combines satellite communication transceivers embedded in containers with ground station networks processing location data, route deviations, and estimated arrival times. This solves the dark zone problem where cargo disappears from tracking for days crossing Central Asia or Africa. The real impact is predictive logistics. Knowing a shipment is delayed in Kazakhstan lets you reroute production before it becomes a crisis. Impressive on paper, but limited by ground station coverage in contested regions where some countries restrict Chinese satellite networks. The track record? Over 8 million containers currently monitored with 94% uptime. But monitoring alone doesn't control the physical flow, which is what number 3 addresses. Number 3. AI-coordinated freight networks. China operates the world's most extensive intelligent highway system, with over 120,000 kilometers equipped with vehicle-to-infrastructure communication. These are operational trials recording real convoy coordination, autonomous freight trucks maintaining optimal spacing, sharing weather data, and rerouting around congestion in real time. The mechanism layers several technologies: roadside units broadcasting traffic conditions, onboard systems adjusting speed and routing, and central platforms optimizing network flow. This isn't about individual vehicle autonomy, it's about system-level orchestration. A human-driven truck might optimize for its own delivery time, but an AI-coordinated network optimizes for total throughput, sometimes slowing one vehicle to create gaps that speed 10 others. The consequence is capacity. Existing roads can handle 30 to 40% more freight volume without new construction. Impressive on paper, but limited by integration challenges with non-equipped vehicles creating mixed autonomy problems. The system works best in controlled corridors, which explains China's focus on dedicated freight routes. Now watch what happens when this capability extends to the next scale. Number 2. Unmanned cargo vessels and intelligent port integration. China's Zhifei is the first large-scale autonomous container ship operating commercially, completing a 56-hour voyage with 0 crew. This is recorded during actual operations, not simulation. Now watch what happens when this scales. Autonomous ships coordinating with automated ports eliminate the scheduling friction between vessel arrival and berth availability. The technology uses collision avoidance radar, weather routing algorithms, and automated docking systems that can berth within 5 centimeters of optimal position. This matters because crew costs and scheduling delays represent 40% of shipping expenses. Remove both, and you've restructured maritime economics. The limitation? International maritime law isn't designed for crewless vessels, creating regulatory uncertainty. Which brings us to the technology that makes all of this strategically coherent. And at number 1, integrated supply chain operating systems that coordinate entire industrial ecosystems. Picture a drought hitting battery material mines in Chile. Within hours, the impact ripples through electric vehicle production schedules in Shanghai. Not through panic, but through algorithmic reallocation. Purchasing systems automatically source alternative lithium suppliers, production schedules adjust output rates, and logistics networks reroute in-transit materials to factories with immediate need. This isn't hypothetical. It's China's industrial internet platform processing real disruptions. The system is called I3, Industrial Intelligent Internet. A unified data layer connecting manufacturing, logistics, finance, and government systems. The mechanism? Shared data standards allowing machine-to-machine coordination across company boundaries, with AI models continuously optimizing for cost, time, and risk. This changes the decision space from "what should we do about the disruption" to "the system has already rebalanced, approve or override." Why it matters? Supply chains are control systems. Whoever operates the fastest, most integrated control system makes decisions that others must react to. You're not negotiating prices, you're accepting algorithmic allocations. The limitation? The system requires trust. Companies must share operational data, creating dependencies some nations find unacceptable. Realistic timeline. Partial international adoption in specialized sectors within 5 years, full integration unlikely until unified data sovereignty frameworks exist. Technologies like integrated supply chain operating systems show where industrial strategy is heading, not in military demonstrations, but in infrastructure that makes alternative choices economically irrational. And the next wave of strategic capabilities won't announce themselves with press releases until they're already indispensable. Subscribe and hit the bell if you want clear, evidence-based breakdowns of the technology shaping the future.